Welcome. I'm Carrie Donnelly, the director of the Chapel Hill Analytical and Nano-Fabrication Lab, or CHANNEL, at UNC. With me today is Catherine McInnes, a graduate student at UNC.
Hello everyone. Thanks for joining us. Today I'm going to show you how to prepare samples for scanning electron microscopy, or SEM. Let's head to the lab. Welcome to the SEM lab. Today we will be imaging some salt crystals. The tools that we will need to prepare our sample for imaging today include the sample, tweezers, sample stubs, conductive tape, two common types are carbon tape and copper tape, and possibly a sputter coater. First, I'll mount the sample onto a sample stub with some conductive tape. The tape I'm using is double-sided carbon tape, and I'll use it to hold the salt in place. By gently tapping the sample stub on the table, I can remove any excess salt that is not well attached. Samples that are not conductive need to be coated with a conductive coating for traditional SEM imaging in order to prevent charging problems. Our lab uses a sputter coater to deposit a thin layer of gold palladium, but some labs use a carbon coating instead. I'll place the sample in the sputter coater. The metal that we will deposit is actually held in the lid, and this small circular disc just next to the sample is called a quartz crystal microbalance. It can measure how much material has been deposited. After loading the sample into the chamber and closing the lid, I can evacuate the chamber using a vacuum pump. Once the chamber has been evacuated, I can start the deposition. A plasma is generated that removes material from the gold palladium target and deposits it everywhere in the chamber, including on my sample. It's easier to see this plasma if we turn off the lights. The readout from the quartz crystal microbalance lets me know how much material has been deposited. A 2 nanometer coating is usually sufficient to prevent charging. If your sample is conductive, or if you will be imaging in an environmental SEM, you can skip this sample coating step. Our sample is now ready for SEM imaging. Let's head to the imaging lab.